Hey guys, Pankaj here. Welcome back to my YouTube channel. In today's EDA part, I'm going to talk about text data, and this text data is based on from Twitter handle. Okay, so there will be so many user which will be commenting to other user, and that comment is whether it is a cyberbullying data or cyberbully type of text data or not. That is what we are going to see. Okay, so this data will be used for machine learning, whether to predict whether the given text or given commented data is cyberbully data or not. Okay, but today we are not going to do prediction. Rather, we will be doing some exploratory data analysis on this text data. Okay, so let me share my desktop. Okay, so this is the notebook. As usual, I have mentioned about EDA, what is EDA, how to do EDA, and what are important or various fundamental steps to perform in EDA. Okay, so let's start with this step where I'm going to import all the necessary libraries. So we'll be importing NumPy. We may need it later. Pandas as PD for reading the data frame. Matplotlib as PLT, C1 as SNS. And since it is text data, so I'm going to import another library called WordCloud. So those who are not sure about WordCloud, go back and watch the specific video where I've talked about like how to visualize the text data. So from WordCloud, import WordCloud, and I'm going to use stop word as well because we may have to do during cleaning, we have to use uh, data which is not having stop word. Okay, so we may use it for removing it. So let's go ahead and import it. Okay, now data is imported. Let's read the data now. So as usual, I am going to create df as variable data frame pd dot read csv, and here we have data called cyberbullying tweets dot csv. Okay, so we are not going to open any Excel sheet or CSV sheet. Okay, everything we are going to do through Pandas data frame. So let's run it and see. df dot head 5 top 5 rows, and you can use tail bottom 5 rows also. So in this you'll see uh, we have only pure text data, which is tweet underscore text feature, and under cyberbullying underscore type feature we are having what kind of type it is. So under cyberbullying, whether it is cyberbullying, not cyberbullying, or there are a couple of other categories we'll see later. Okay, so only two very small data set, but only two features. Okay, so let's go ahead and see the next one. Get shape of the data and say number of different observations. df dot shape. So this has total 47,692 observation along with two features, that is tweet text and cyberbully type. Okay, so less number of feature but more number of observation. So get feature names of dataset. So it is not really required because we clearly see it is only having two feature, but nevertheless, there's no harm. So let's go ahead and watch it. So as I mentioned, df.keys or df.columns both can provide you number of features or name of the feature which is used in the dataset. Okay, so get full description of dataset. These things we cannot use because there is no numerical value. However, there is another option under describe which will visualize the text data as well or object type data. Okay, so let's go ahead and use it. Describe. Okay, under this there is one option called include. Okay, so by default it will include only those feature which is having only numerical data. Okay, so let's see what and all other options are there under include. So we have all list like of, okay, default option. Okay, so all means all comma of the input will be included in the output, no matter whether it is numerical or object or both. Okay, and a list like of data type that limits the result to the provided data type. In case we provide, then it will list. Okay, so what I can do is I'll just mention all. Let's see what it does. Okay, so it is telling tweet text. So both the text feature it has included and cyberbullying type. Okay, so count total number of entries it is telling. Unique total number of unique values 46017. There could be some repeated value. Looks like close to 600 values are repeating. Okay, cyberbullying type. So this type is like total 6 different categories are there. Remember, guys, this is very helpful. So for numerical, we have seen in two different data set, but for text data also, you should understand like how and what kind of data or what kind of statistical detail it provides in the describe function. Okay, so 6 means it is having total 6 number of categories. We'll see what kind of those categories. Okay, top is nothing but this one, which is more number of time it has been repeated. So maybe this is the one which is being repeated couple of times, or maybe so many number of times. And this belong to which type? Religion type. Okay, frequency. So total 2 times. Okay, it is coming 2 times. And cyberbullying type, it is coming total 7998. So basically this religion type is coming 7,998 times. Okay, so we'll see it later also. So this is how you display string data as well. Let's see the info part, what it does. Okay, so it is having two data, two column name, tweet text, cyberbullying, total object type, and total memory use is 745 kilobytes. Okay, and total non-null entries or total observation 47,692, and type is object type, which we already see. And there is another way to check the type, that is nothing but df dot d types. That is nothing but data types. Okay, so this will also do the same thing. Okay, up to here it is fine. We have all basic data info and complete information on the data set. Let's go ahead and the next one. To understand the data type of data set and downgrade its type. So this is not required because it is text data. So I'll just mention not required because it has purely text data. Okay, see if any missing values are present in the data set. Let's see df dot is null dot sum. So none of the features are having missing values, so we are good. No need to do any replacement. Okay, get unique values of each feature. This will help you to get to know if any unwanted characters are present in the dataset. So this is also not required, but however, as I mentioned, we have two features, right? And one feature is having pure text data, and another feature which is cyberbullying type. What kind of type or what kind of categories are there? So this makes sense to use the unique values. So let's go ahead and check df dot cyberbullying. This is the a feature name. So there are two ways, right? Either dot notation or bracket notation. Okay, so I'm going ahead with dot notation here and apply unique function. And let's see what are all unique functions are there. Okay, so it has how many? Not cyberbullying, gender, religion, other cyberbullying, age, and ethnicity. So these are the different categories under cyberbullying. Okay, so we'll analyze it separately. What kind of word they are using, what kind of bully word they use for these kind of categories. Okay, so this is one thing, and let's visualize this particular data also. df dot cyberbullying dot value counts. So this will give you the exact count of those data. Okay, so as I mentioned earlier, also pandas has default data visualization. Okay, so the moment you get all the data frame about their counts, here only you can apply plot kind equal to bar. Okay, so this is another way to do visualization. Of course, you can go ahead and use matplotlib as well as seaborn. Okay, so since it is already providing, it is a matter of just using inbuilt libraries. So you don't have to always use matplot or seaborn whenever visualization comes into picture. Okay, there are some short way. So like here I've used pandas default data frame visualization, which I think you should use it. Okay, so since there's no visualization for this, we do have visualization, but there's no missing value. So you can just use sns dot heatmap df dot is null. So it is not going to show anything because it doesn't have any missing values, correct? What is this? df dot is null. Let me just quickly check what it does. Okay. It is showing true false. Okay, we don't have any values. I think that's why it is not showing anything. Inconsistency between the condition and the input got 2, 1. Okay. dot sum. Okay, only two categories are there. It is not able to show it. That's fine, no issue. So we don't have missing value, so no need to visualize it. Let's remove this part. Okay. So decide if feature needs to be dropped. So we have only two feature, no need to drop them. Fill missing values. There is no missing value, so we are not going to fill anything. Find out correlation. This is also not required. So I'm just going to mention any. Not required. Find out highly correlated feature. It is also not required because there is no missing values or no numerical features. Find out feature which needs typecasting. Of course, this is also not required. Okay, this is purely text data. So these kind of steps you can definitely ignore it. Visualize missing values again. So we have not done anything on missing. Let's remove it. Okay, infer insights. Okay, so before doing this, we have a lot of other detail which needs to be taken care while handling the text data. One is like data cleaning. Okay, so let's go ahead and do the data cleaning. So I'll mention data cleaning for text data cleaning. So why this cleaning is required here in the EDA? I'll tell you the main reason, because once we start learning machine learning concept, right, and we do a lot of word to wake or bag of word creation, right? So if you're not going to use stop word deletion or special character which is used in the Twitter handle or Twitter comment, then a lot of different kind of word or special character also will be treated as a single text feature. Okay, so which is not going to add any more value. Okay, so like you will be having a lot of text data related to this because it is Twitter data, right? So you may have a lot of reviews word also which will be used like this. So this will be treated as a single word. Single word means another single feature. Okay, there will be some value which is like used like this, some underscore, something like that, right? Special like question mark and hash underscore like this. So a lot of different non-word characters will be there. If you don't clean, this will be treated as a separate feature. So this is what we are going to do under text data cleaning. Okay, and unwanted spaces will be there, unwanted new line character will be there. Okay, there will be some word which is, let's say, having some name, let's say text. It will start with @ okay, it will start with hash, it will start with dollar. Okay, so those things doesn't make any sense, and it is going to affect your model which you are going to create from machine learning concept. Okay, so let's go ahead and do the data cleaning. So first I will do tf dot, and let's see the feature now. Okay, so t dot text, let's analyze this particular data. So df dot tweet text, it has, it is going to print a lot of things here. So I'll just take, let's say, first 5 values. Okay, so you see here, this is what I was talking. There are a couple of words which is having hash, there are some word which is having @, and there could be so many other things also. Let's analyze last 5 data. Okay, so here, yeah, another than this one, this word is there which is having starting with @, it is having colon, and yeah, so many words. And of course, other than these special character, we have a lot of stop words. Okay, so this makes sense to remove the stop word, otherwise you will be end up with a lot of feature which is not going to add any values. Okay, so how to add? Let's import regular expression also. So since it is text data, we have to do some kind of regular expression processing. Okay, let's go ahead. So first I'm going to remove all the all the non-word characters. What are those non-word characters? Anything other than alphanumeric value. Okay, like hash, @, any special character or any white space character. So go ahead and remove all the space character, non-word characters. How to remove them? So we have re dot substitute. I'm going to write a pattern and I'm going to replace. So you just replace all the special character with space. Later we will do like multiple space will convert into single space. Okay. And if you are going to, if you're not going to put a space, just putting like null character here, everything is going to be merged. It is going to make some different word which is non-dictionary word, right? So be careful while doing this. And where to do that? We will have the text. Okay, so this I'll fill later. So first go ahead and let's write the pattern. Before that, I'm just going to visualize with text. Let's say first entry. Okay, let's take one more here. Okay, you see a lot of words are there. Good that I randomly chosen and I found this. So we do have emojis as well as special character in different language. So we must remove them. Okay, let's see whether it is really removing or not. So what I'll do, I'm going to place any word character. Okay. So under this special, sorry, within the square bracket, if you write any character class, right? So I'm just putting any word character and I'll just negate it. So anything other than word character, let's remove them. Okay, and there could be so many number of characters. Remove them with the space, and where to remove? Let's say I'm having text. Okay, but I'm not going to put for loop and keep replacing one by one, right? So rather what I'll do, I'll create a lambda function. Okay, and you know that lambda function will use apply map or using map function. It will just put that function and apply over all the series data, and it will just do the processing and return it. That's what we're going to do that. Okay, so let's create a lambda function, lam equal to lambda. It needs one variable, and this x is nothing but your text data. I'll just mention here text data, and under this I'm going to call regular expression dot substitute, and this text data to be used as a string here. Okay, so now your lambda function is created, and I am going to use df dot tweet dot tweet text dot. We have something called map, correct? If you apply map and put a function name, so what is my argument? This is the lamb function. So what it will do, it will go ahead with this series, pick each sentence from individual row or individual observation, and provide that or pass that sentence to the lamb function, and later it is going to do this processing. Okay, so let's create lambda function to do bulk text processing animation. Okay, so this kind of processing will be very helpful whenever you have like a lot of batch processing or bulk processing you want to do with the text data. Okay, so let's go ahead and do that. See what is happening. So it has done the processing and it has returned me the whole series. So basically copy of original series where all the special character has been removed. Okay, so this is not what we want. What we want is, let's say we have in place? No, right? So we are going to replace this particular text with updated text. Okay, now our df.tweet underscore text is having clean data. So let's go ahead and use df tweet 0. Okay, so take a look at this and the one which we were having earlier. So 0th was having this particular thing, right? Now you see a lot of changes. It is having very clean text, correct? Now another one, we had taken 21. Let's see what it does. So in 21, it is able to remove all the character of emoji, but not the special character. Like Urdu language is also there. Some Unicode character is there, right? So what we can do right now, I don't know what is the Unicode for this particular word or character, because this is also being considered as what do you say, a word character, right? Because though it is a different language, but it's a word character, right? So what we can do, we can find the ASCII value of this. If you're able to find that, then well, we can put a range like between this and this. Whatever characters come, just remove it. Okay. Similarly, 0x is also there. It is being treated as a character, right? So we can do this kind of processing, provided that you know the Unicode character of this. So to do that, you can put a substitution, maybe another level of substitution by removing these character. Okay, or the ASCII code of small letter A, small capital letter A, small letter Z, and capital Z, right? So anything other than those ASCII character, remove them. So that will be really able to remove it. Okay, so I think this could be taken as a homework for you guys. I have already given the hint, so go ahead and modify that. Okay, so now we have clean data. Let's see what else we can do. Okay, so df dot head 5. Okay, now this clearly very clearly seen like a lot of cleaning has been already done. Okay, so now let's go ahead and find something else. So tweet text data, cyberbullying type. So insight of this data. So count of categorical data, which we have already seen it. So what I can do now, df dot sns dot count plot, df dot so this way you can do, and here plt dot hsticks, because since it is text data, right, it will be very big name, so better you do alignment as 90 degree, rotation equal to 90. Okay, this will look better. Now histogram, there is no numerical data, doesn't make any sense, so let's leave it. Correlation also not required, so let's leave it. These things not required. Let me just comment and we'll do something else. Okay, so finally what we have here, df dot head 5. So if you see, we have a lot of different categories, guys. So in the text processing, we do one more thing. And one more thing, we forgot to remove the stop word, right? So I think we should do removing the stop word thing. So what we will do now, let's remove the stop word to do another level of word cleaning. Okay, so again, I'll read the function here. Let me just show what exactly I'm trying to do. So I know the stop word, what things are there. These are the stop word, right, which is by default from WordCloud. So I'm going to iterate over each sentence, and whatever stop words are there, let's remove them, and whatever is not a stop word, let's count them. Okay. So for that we have to iterate over each thing, right? So let's use another function, lam2 equal to lambda. Take this as a text data equal to, I'm going to remove or going to create a function here, not basically a list comprehension. Okay, so for w in text data dot split, remember guys, I'm doing multiple things under single line, so you will understand. Let me just write it. So I'm going to take the text data, then going to split by space, and I'll get the list of all the words from this single sentence, right? And iterate over each word and find out if W not in stop words, then use a W. Okay, so what you will do basically, let me just show you first. I'll take one data and just show you, then later we'll merge it. Okay, so here what I'll do, lam2, and I'm just going to provide one data here, df dot read text data and take the first observation. Let's see what it does. So it has taken the complete sentence, it has split it, and whatever is not there in stop word, let me just remove this first. Okay, so I'll show before and after. Let me just go ahead and comment. See what is happening here. So if you don't remove stop word, it is going to take everything into count, and it is just going to show everything, correct? And later, once you have all the word, you do one thing, you just join them together by space, so that you'll get the whole sentence after removing all the words, correct? So this is finally we got. In other words, this and this, something is there, right? So what we are gaining here, we are not at all gaining the new sentence by uh, removing the stop word, because we haven't removed, we have commented this, right? Now what we'll do, we'll go ahead and just take this, comment this part, or maybe I will leave it to you guys so that you can also try. Okay, I just mentioned after removing stop word, you will see the change. So what I'm going to do now, let's uncomment, remove this part, and later getting the list of word, I'm going to join them together. Dot join. Now you see the magic. In words, this, you see other is removed, your is removed, was is removed, and if you want to consider mkr also as a stop word, go ahead and add or append in the stop word list. Okay, so this will also get removed. So I think for now it is good. We are able to fetch these words. Let's use 21. Maybe I'll use, let's say, 90 something, right? Okay, and let's use here also, just one comment. I knew this, someone, T code. These are not stop word, that's why it has taken. So you can do another level of filtering by removing all the word which is like single letter. Okay, mostly after let's say if you are removing single letter, I will also be gone, right? So it makes sense to remove them because it is not going to count, not going to add any value in the data set. Okay, so overall idea you got it. We have just removed the stop word. Now let's go ahead and apply this function. df dot tweet dot map lamp2 and modify this particular text. Okay, now go ahead and df dot head 5. So you will see big change here. Take the original one and compare with this. You will see a lot of what have been removed, stop what have been removed. Okay, so now we are good. Okay, so stop words are removed, and we did the data cleaning by removing all the unwanted characters from the given text. Now what next? Now another thing we have to do is whenever you have this kind of category feature, right, or categorical feature, so it makes sense to change the text into a numerical value, because that's what machine learning algorithm is going to understand. So this part I'll explain later, how to convert into numerical value, which will be bag of words. But for time being, let's consider only this because these are having less number of values, and it makes sense to put a category like 0, 1, 2 for given each category. Okay, so there are 2-3 ways to do that. First, I'll show one thing called, let's add category, or maybe in code I'll mention, let's encode text. You will understand the importance of this once you go ahead with the machine learning algorithm. Okay, so we have something called pd dot, there is something called hot encode. Let me just find out. Okay, cyber bf dot cyberbullying type dot get dummies. Why it is not coming? pd dot get pd dot get dummies, not on the series. We have to pass the series name. Okay, so pd dot get dummies, what it does, it takes the data and which particular column you would like to apply. Okay, so let's give this particular name. So I'll show you what exactly it is doing. And your data is df. I think I could have mentioned the column type as columns. So it should be list like structure. So I have to pass this in the form of list. Yeah, this makes sense. So let me explain this with the help of whiteboard. To make it clear basically what exactly it is doing in the background. Okay, I'll connect my whiteboard. So okay, so let's say you have one column here. Let's say A, B, or okay, let's remove this one, or C, or this is okay. And here we have, let's say, some column called target. Okay, you have some value here 0, 1, 2, let's say 11.2, 11.3, 14, 4.9, some value. Okay, and target, let's say you have yes, yes, and no. Okay, so let's say you have so many values here, and later when you are going to pass this whole data set into machine learning, right? So these things are fine. This is already having numerical data. A and B is also numerical data, right? But what about target? This is not a numerical, right? It is having some category where we have yes or no, two values, right? So what we can do in the get dummies, it will do one thing. So target will be converted into yes and no column. So we will have A, we have B, A will be 0, 1, 2 as it is, 11.2, 11.3, 4.9. But what about yes? Do we have yes in this particular observation? Yes, so we'll make it 1. For this also we have 1. For this particular observation, we don't have yes, right? So this will become 0. Okay. And for no, do we have this? No. Do we have this? No. But here for third observation, we have no, right? So this will make it 1. And this is what is your get dummies. Okay, so this kind of transformation is required whenever you have this kind of categorical value which is in the text format. Okay, so that is what it does. So cyberbullying, it is not there in the 0th observation. That's why we have put 0. It is kind of like cyberbullying type, not cyberbullying, right? So it has given 1. So that's what it is going to iterate over each observation, and for all 6 categories, it is going to put these kind of category. Okay, so get dummies is one short way to do this kind of category. Another way to do is use replace. That is also fine. So what we will do, I'll just mention here using get dummies function. Now here I'll show, I'm not going to use it. Okay, so I just showed you because you guys should know what is get dummies and what is the other way, using replace function. Okay, so disadvantage of this is unnecessary. It is going to add more number of features. Let's say you have 50 different categories, right? So what it will do, it is just going to add those 50 different column name or feature name in the given data set, right? So which is not a good idea. If you have 2, 3, it makes sense, but 50, I would not suggest to go ahead with this. Rather, we'll go ahead with replace function. Okay, so what we can do now. So what is that category? Cyberbullying, right? Cyberbullying dot replace, and here first you should understand what and all types are there. Dot unique. Okay, so we have these 6 categories. So what we can do, you just copy paste those names and put in the form of dictionary. So first is like not cyberbullying, you make it as 0. Then we have gender. So let's go ahead and add gender column. Let's say for gender I'm giving 1. For religion I'll give 2. For other cyberbullying I'll give another category as 3. Then age I'll give 4, and ethnicity I'll give 5. So having this kind of small values and very compact what do you say categorization using numerical value will make sense, because once you do prediction using machine learning algorithm, right, it is going to predict 0, 1, 2, 3, or 4. Okay, so ethnicity I'll give 5. Okay, so now replace, you can use in place it true, or you can just give this also, anything is fine. Okay, now let's go ahead and df dot head 5. Okay, and df dot cyberbullying type dot unique, just filter out one second, 0 1 2 3 4 5. Okay, so now we are almost ready. This I'll show later once I talked about machine learning, how to convert these text into numerical value, okay, which is known as bag of words. So we'll see that. Right now it will not make sense, that's why I'm not talking, but this was required because whenever you see this kind of category, go ahead and just use get dummies for less than 2 3 or 5 features. Otherwise use replace method to add whatever numerical value you want to give to those categories. Okay, so now we are good, and let's go ahead and find out their count. Okay, so what we will do now, we will find out like what kind of next analysis. What we are going to do is like for which particular cyberbullying type, what kind of word they have used, and we'll do some visualization. Okay, so for visualization, first let's go ahead and do complete visualization of the complete given data. So let's complete with data in WordCloud. So to do that, you should have the complete text into one single statement, right? So what I'll do, I'll just go ahead and join them. So df dot tweet. So I'm going to join them, right? So join with the help of space dot join, and just give this. So it is going to give me one text, which is like single word. It has gone through all 47,000 statement or observation, merge them together. Okay, this is my single sentence. Okay, so that's all. And now what we will do now, I'll just use text equal to this. Okay, now let's create word cloud object here, word cloud, and let's go with default values first. So we have font path, width, height, margin, and yeah, this is okay. Now from WC, I'm going to use image generation, WC dot generate from text. What is my text data? TXT. Okay, now image text will be generated and I'm going to plot them. plt dot imshow text, oh, sorry, image. plt dot show. Okay, so this is what the word cloud, what kind of word they are using in most frequently, what kind of word they have used. This is the way to visualize. Okay, so let's make some beautification here. plt dot figure 6 size, I just mentioned maybe 10 by 6, fully bigger. Okay, and here I can remove background color as white. Okay, and let's take out the plt.axis. Okay, so this is what like these kind of bully word they have used in all kind of cyber bully text in the Twitter data. Okay, you can infer a lot of things. So and this is like as a whole data I have done, right? Now what we'll do, I'll just show once and later you can do as a practice for other cyber bully type. Okay, so let's find out for gender type what kind of most frequently word they have used. Okay, so let's figure out what word is used frequently for gender bully type, I'll mention. Okay, so we have df dot head. How to find out that? Okay, so first you should understand, we will take this bully type, and what is the category you have given for gender? You have given one, right? So what I will do now, gender equal to 1. Okay, we have used gender equal to 1. So df dot cyberbully type equal to 1. So go ahead and find out all the data where cyberbully type is equal to 1. Means wherever gender type bully is there, right? Extract those text data. Okay, now you have extracted those text data and go ahead and merge them. Okay, so I'll just use temp df equal to this. Okay, temp df dot head. So if you are able to do this, what you can do, you can apply same thing now. Okay, so go ahead and use the image or generate the image for the text data. So my text will be t2 equal to temp df dot tweet text, and tweet text, let's join them and make the single sentence. Join, you can write a function also, but I'm just showing you guys internally so that you can understand the step-by-step process. Okay, so this is my T2. Let me just comment. And this text is having only those gender bullied kind of text data. Okay, let's go and visualize it. So wc dot, sorry, image equal to generate from text, and this is my text data. And let's go ahead and use this same thing. Okay, image 2, image 2. Let's generate the image, use this. See the big difference for gender type, what kind of word they are using. Okay, and probably I'll go ahead and just use some other word also. So let's talk about age related, right? Do we have age? Yeah, we do have age. Or maybe for religion, religion is 2 type, correct? So what I can do now, where is the comment part? Okay, so this is this religion type 2, and here I'll mention 2. Okay, and let's go ahead and just do that. Yeah, so for this particular type, what is that? Religion type. Okay, so 2, they are using these kind of word most frequently in the cyberbully tweet data. Okay, you can get the count also. You can just definitely get the total count and just do the visualization. So let me just visualize the most frequently used word. So we have the text data T2. So let's use word frequency. So if you guys remember in Spacey or analytic I have shown, right, how to generate the word frequency. So best and shortest way to do that is using dictionary, right? So what we'll do, op equal to, that is output, t2 dot split them with the help of space. Okay, now we got this. And how does it look? It will be just space separated values. Okay, so it is too big, so I'm not going to visualize it now, and I'm going to iterate over these words. So let's say w, and here op dot count w for w in op. So it is going to provide me the frequency of those words which is occurring in the output. It is going to be very big, so that's why it is going to take some time. But once you get the count, you can do the visualization. So what I'll do, I'll just filter out maybe first 1000 word. Okay, equal to, just to show you guys. I mean, first 500 should be okay. Let me interrupt it. 500 and 500 words should be okay. And once you have these 500 words, let's say frequency equal to, now let's go ahead and plot SNS dot, let's say we have count plot, not count, basically bar plot. Okay, so frequency dot keys, that will be your x-axis, and frequency dot values will be your y-axis. Okay, so what happened here? Bool object has no attribute all. Okay, what else we can do? Plt dot bar frequency dot keys, that will be your X data, and it needs height equal to frequency dot value. This should work. It will work. PLT dot figure dot fixed size 16.4 PLT dot xtix rotation equal to 90 PLT dot show. Let's see that. Okay, so many words. Maybe we can limit to 400. 200 also should be okay. Yeah, so out of those 200, we can definitely, at least we are able to see the text as well as their count, right? So this should be good enough. And later, if you want to remove, or you want to what to say, you want to show more data, right? So what you can do, you can do the sort, and from sorting, like ascending order or maybe descending order will be a better idea. And from descending order sorted value, you just take first 100 or first 200 value and do the display. That is also fine. So in number of ways to do the visualization. Okay, so plt.xtix, and what I'll do, font size equal to 2. I hope it will work. 2 is too small, so I'll just take 7. Yeah, should be okay. Maybe you can make 20 by 7. Make it bigger so things will be displaying it properly. And give it 10 or 13. 12 should be better. Okay guys, so that's all about this particular EDA. I think from this particular two data, this is what we can do best. And later, one thing is pending, which I'll show in the machine learning. Okay, how to create bag of words. And we'll do the prediction part also, so you will understand what extra we can do with the text data. I'll take 1 or 2 more text data, which will be very similar, but couple of other different kind of processing we can do. Okay guys, so that's all from my side. I hope you liked it. Please leave out the comment in the comment box. And if anything which is not clear to you guys, just put in the comment box. Okay, I'll definitely go ahead and explain in the next video. Okay, thank you so much. Bye-bye.